The problem number
51. 51A.
so 51A is that. You know, this this acid contains 3 hydrogen atoms. It means the process of hydrolysis can occur in 3 stages. You know, that's why 3 types of the salts can form. So, for example, the first stage, the first stage was the base, and it forms BO3 and phosphor. As you can see, in order to in order to make the first stage happen, we need the 1 moles of the potassium hydroxide. For the second stage, we have to add 1 mole extra potassium hydroxide. And then we take this salt, which contains only 1 hydrogen atoms. So the same goes also the third stage. In the third stage, you have to add extra potassium hydroxide. So you understand?
Why are we doing it in 3 stages?
Because in the hydrolysis rules, the multiple acidity acids should hydrolyze in stepwise character. All of them. It can be sulfuric acid also, because it contains the 2 hydrogen. The acidity is equal to, and it can hydrolyze in 2 steps. And also, this reaction is called the neutralization. It's not a hydrolyze. It is a neutralization, but the formed salt can hydrolyze with water molecules. That's why here the role of the hydrolysis exists also. And your task is you have to find the ratio. You have to find the ratio. Uh, for example, the first stage, in the first stage, the ratio should be 1:1. In the second stage, if we don't consider this calcium, this potassium, the ratio looks like this. So 1:2. Okay. So if you don't take this potassium into consideration, the ratio looks like this. And in our case, the ratio,
Why are you crossing out potassium?
because this is a summary of the reactions, the final reactions. Uh, in reality, if you get 2 moles of the potassium hydroxide on your solution, so this acid begins being spent, and the first stage occurs. After that, the second step occurs, and then the reaction being complete, and it can't continue the third stage because the moles of the potassium base is limited to 2 moles. That's why uh, the second stage is the final reaction, and the the summary reaction, of the summary equation of this reaction should be looks like this. Overall, you've spent two potassium hydroxide, okay, for the 1 mole. Is that clear?
Okay.
If you have 3 moles, you can continue this reaction till the end, and the final total reaction looks like this. Do you have any question about this? And in your case, here the acid is uh, multi multi-stage um, multi-stage acid because it can neutralize with multi-stage. So, and in your case, the ratio is equal to 1 divided 1 by 1. Okay, and that's why you are spending 1 mole for acid and base, and the product this salt, and when these salts dissociate, 2 hydrogen cations forms, and you have to calculate these hydrogen cations. Okay, 1 mole forms 2 mole hydrogen cations. And how many moles exist? How many moles did you found? Can you tell me?
What?
Can you remember I sent you on the Telegram the solution of the problem? And in this solution, we found the moles of the acid, yes, and also the
Yeah.
moles of the salt.
Yeah, they were same.
Yes, this is the same, the 1 mole, and I think it's equal to 0.005.
5.
0.005 and 0.005 moles of the salt forms. Is that clear?
Yes. So why won't we find the pH?
Okay, you know the meaning. Do you know the meaning of the pH? pH, it is the concentration of the hydrogen cations.
Okay.
And after this salt forms, it
Will
begins.
I multiply 0.0 no, by 2?
Yes, and then you can find the concentration of the hydrogen cations. Imagine they are attracting with water molecules, and it forms this one and the hydrogen cations. It's just two hydrogen cations. So is that clear?
Isn't this a weak electrolyte?
Yes, it is. I think it is. It is not a weak. It's not so weak. It's not so weak because it contains the hydrogen cations. After you find the concentration of the hydrogen cations, and then you can calculate the pH. Can you find this?
I don't understand. So 0.05 is for the first one. So what's the molarity of water?
You don't need the water. You need the hydrogen concentration that forms after this hydrolysis reaction. It's self-evident, as you can see, because salt contains two hydrogen cations. Two hydrogen cations means the 2 moles. If 1 mole of this salt
Well, I
dissolves,
divided by 2.
no, you have to multiply by 2.
0.005.
Yes, 0.005 multiplied by 2, it's equal to 0.01. This is the concentration of the hydrogen cations. And then you have to calculate the logarithm of this concentration. It's so easy. Why are you hesitating?
After that, what do I have to find?
Mm,
After 0.01.
you have to find the,
The log?
yes, logarithm. You know, the pH is equal to logarithm
Negative log.
of the hydrogen cations.
Yes, I know.
If you forget this,
But for this, why won't I find POH?
you don't need the pH. The problem asking you pH. You don't need the pH.
Okay.
By the way, what about the volume? You have to
We
check
already
because
used the volume to find out 0.005.
we have to also divide the volume because here the volume is not 1 liter. It's
That's what I said. That's what I said while you were explaining. I said that after that, do I have to divide 0.005 by 0.03? And then you said no.
yes, you should have mentioned the volume. That's why I didn't get the exact number. Where does this 0.03 came from?
Okay.
And then you can calculate. Divide 0.01 by 0.03 and then find the logarithm and tell me the answer.
Wait, wasn't I supposed to divide 0.005 by 0.03? And then I would have to multiply 0.16, the product of 0.005 divided by 0.03, multiply that by 2.
Why are you multiplying? We've already multiplied these two.
Yes, but then that was the before, when you explained, we first found out
Okay.
we first divided 0. For example, here 0.005 by 0.03, the total volume, and then after that we'll multiply it by 2.
Where did you check that to? Exactly.
So
That,
was it supposed to first multiply it by 2, then divided by the total volume?
yes.
Okay.
We've already found the concentration of hydrogen patients. Why do we
But
need to? I've never
before
seen it.
finding it, wasn't I supposed to divide it by 0.03?
Yes, that's it. And then find the logarithm. You just, I don't know where you took these two. You, if you mentioned, if you're intending these two, you've already multiplied, you found the molar moles of hydrogen patients. So, can you hear me?
Yes.
Did you get it?
The answer, the answer will be 1.5. The
Concentration
pH.
1.5. This is the concentration of the hydrogen.
The pH is 1.5.
Yes. Answer that. Answer this 1.5. Did you get it?
No, that's
So
the answer of this. The answer of this is 0.33. Then to find the pH, I have to do the logarithm. The logarithm of 0.33 is 1.5, which will be the pH.
now I get it. That's why the answer is 1.5.
Yeah, the answer is 1.5.
Yes. That's why I'm telling. So what kind of misunderstanding do you have for this problem? What kind of,
The only problem that I had is was with the ratio.
yes, um, when it comes to the multiple hydrogen containing acids, the ratio can be different according to the moles of the reactants. But here there is no alternative reaction because only one step exists for the second step. There is no second step and then the third step. There is no alternatives. That's why when it comes to the multiple hydrogen containing acids, you have to be careful. Just and find the ratio and write the reaction and which step can be enough to be occurred, and then find the concentration of the hydrogen cations. That's it. Is that clear?
Yes.
Okay, solve the problem number 21st and B problem. Don't you need it? Shall I erase so that you can use my space to show your answer?
What?
Don't you need
21?
this calculation? Don't you need this calculation? I'm gonna erase it.
No, I'm done. Yes, you may.
Okay. And what should you do right now? I've assigned you this problem. Have you solved this
No,
problem?
I did 49 out of 49.
You need 49. You can do this, yes?
No, yeah, I did 49.
So you did 49.
I've already done it. I've completed. But I didn't send you it because I had done it in the rough. I need to write
Yeah.
it
You
properly.
should say the 49 and the 51 are similar each other, but the numbers are different.
Yeah,
Okay.
but I understood this.
All right. And what else that you couldn't do? So do you have any questions about this homework? By the way, have you finished all of them?
No.
So conclusions. Find the conclusion to assume the handle the first step. Here, as you can see, the first step only. Calculate.
What?
Here, the problem intending that you should only use the first step because these salts can hydrolyze in 3 steps. This one is a 2 step, you know, because the residue of acid contains the multiple hydrogens. Haven't you learned the stepwise character of hydrolysis?
No, we just did it in one line.
No, I've explained the
We didn't do it stepwise.
stepwise characters of the hydrolysis. I've wrote this. Why can't you remember?
Right now? The one that you do right now?
Yes.
The one you showed me right now, I understood. But before we didn't do it stepwise.
On my handouts, I've also incorporated that concept. So can you remember how to shift the direction of the hydrolysis reactions?
Yes.
And meanwhile, um, I've also explained how to shift the stepwise reactions into from left to right. The sending,
Yeah, I remember left to right.
yeah.
It's
In that
diluting,
section,
reversible reactions, and then heating.
yeah, in that section, I've also explained the stepwise characters that bear in your mind. Stepwise character of the hydrolysis can can be relevant to the um, multiple hydrogen containing acids. Okay, and these salts also, the salts which were formed by the multiple hydrogen containing acids. Is that clear?
How do I do stepwise?
So stepwise, as I wrote before, the index here, the index of the metals can can tell you the stepwise character. Stepwise character. Okay? You know, I'm gonna write several acids, and I'm gonna write the salts of these acids. So neutralization steps 1, 2, 3. Hydrolysis steps 1, 2, 3. So did you realize the law behind this calculation? In these acids we have one hydrogen, in this two, and this one three. And the salts, one metal, two metal, three metals. And based on this, the steps can be identified. Is that clear?
Based on the hydrogen and the metal?
For the acids, the hydrogen, but for the salts, the metals. Okay? If the metal is one valent, but for this, it is not similar. I think it's also similar. I guess hydrogen. Yeah, position. Because just just find the origin of the acids. Does it contain hydrogen or one hydrogen. And if it contains the two hydrogen, the stepwise reaction can occur in two steps. If it contains three hydrogen, you should tell the three steps. Did you get the law? So do you have any questions how to find the stepwise character of salts?
For salt, it depends on the metal.
So yes, metals can identify. So in the salt, you have to notice the metals, and then the residue of the acids, and neutralize reactions. You have to notice the acid itself. Okay. So I'm gonna write a reaction, and then you should tell me how many steps can occur for this hydrolysis reaction. Can you tell me how many steps?
One,
One. So
three,
yes, and based on what you predicting?
based on the metal,
Metal.
potassium.
Yes. Okay. So now you can predict the stepwise character of the salts. And what else? What kind of difficulties you find for solving these problems? Just tell, this is a high time to ask the questions, or I don't know, I have no clue why you keep this hours, wasting your time.
No, so like, how am I going to divide it into three steps?
So because of the character of hydrogen and the water
Why
molecules,
can't I just write hydrogen with potassium and then potassium hydroxide? Why do I have to divide it into three steps? How will I divide it into three steps?
because in a practical life, the salts cannot, the reaction of the hydrolysis cannot occur fast when it comes to the multiple step salts. Okay, there because it requires energy. It requires energy for the first step. The energy is and the energy that can be required is enough, but the second step is not enough. We have to heat the solution, or we have to dilute the solution in order to make the second step occur. But when it comes to the third step, you have to give the extra heating for the solution, or you have also more dilute this solution, and then you can reach the third step. It's it's more about the energy.
Can you show an example for 52 or 53?
Okay. For example, this is a um, stepwise reaction. Stepwise reaction. for the hydrolysis. This is the first step. This is the first step. So one, two. Okay, is that equal? Let's check. Here we have to put also the hydrogen. Okay, can you count the the oxygen atoms so that we can show
10.
10, right?
10 on the right side. Yeah, they're equal.
Okay, as you can see, in the first step, the base is not forming totally because the collision between the molecules, for example, this molecule is water molecules. These water molecules these are water molecules, and then this is the salt molecules. So each movement of these molecules requires energy. For example, this circulating and clash this, and the reaction occurs. This one also circulating the clash this one, okay, and the reaction occurs. But these molecules spend their energy in order to move their body, okay, and they reacted with this salt, and in order to continue the second step, they need extra energy. That's why when you heat the solution or dilute the solution, the reaction of the hydrolysis can accelerate. You know, each movement
Okay.
requires energy. A car, when you burn the hot fuel, when you burn the fuel, the car moves.
What will happen in the second step?
So, your question?
What will take place in the second step? What will we add?
In the second step, you see the extra water molecules can clash with this salt and forms the total molecule of the base. Is that clear? As you can see, we don't have any incomplete molecule which remained uh, unreacted with the water molecule. As you can see here, the hydrolysis is complete. This is the second step. And the second step also, the water molecules can take part. If you think deeply about this single concept, your mind can be blocked. You just uh, you just block in your mind. Just realize this as it is.
Your voice is breaking.
So,
Can you repeat what you said?
so I'm saying, if you think more about this concept, your mind began being blocked. You know, your mind get tired. Just conclude what you see and what you understand, and don't think deeply, because it's not the time to think and dive into a deep ocean. You just going to the deeply, you know, why this one is uh, as it is, because you know, everything is complex. Now we have to generalize, we have to find a general concept of everything. Here, I've explained the general concepts of these reactions, I mean the stepwise reactions, and you said why this stepwise reaction exists, because of energy. And what kind of energy is it, you say? I've explained it. The energy is needed to move the molecules, and you are going to give me another questions, and you just diving into a deep ocean, and you're gonna say what is the energy itself. Okay, the energy is a force that is needed to move everything: heating, electricity, and nutrition, also energy. Okay, it is
Okay.
more about the physics.
Yes.
Now, did you get why the stepwise character of the salts exists?
Mm-hmm.
For example, I can explain this concept from real life. Okay, so, and you're gonna travel to US. Okay, you're gonna travel to US by bus. Let's say by bus, not airplane. Okay, by bus. And by in order to get the US, you have to, for example, you have to cross the three borders. Let's say the first one Russia, and then the second one the Europe. Okay, so the first step, you cross the Russia, this is the first step. You spend your time, you spend some kind of documentation or some kind of um, actions that is required for cross the Russian border. You cannot just cross the Russian border by speeding your car and clashing the borders and the soldiers. You know, everything has its rules, laws. Okay, you need first of all your documentation. You need the also other uh, passport maybe or the authority. You need that kind of actions. That is called the energy in chemistry in the hypothetically way. Okay, and the second step, mm, you have to cross the Europe border, and you have to show your documentation, show your identification, and you should express your uh, purpose clearly, and then you can cross the Europe. Okay, that's why in order to make the second stage happen, you have to meet the requirements. You need the energy, you have to heat, you have to dilute the solution. That's it, and then you can complete the reaction. You can reach the US. That's all. But when you have planned the requirements that you may encounter uh, in advance, then you can fly. I mean, you can travel um, by plane, and by on the first step. That's you just fly and also go to the US. That's why if you have the extra heating and or extra concentrations already prepared, then you can and then you can complete the reaction. In your case, the first problem that you asked me on the Telegram, we have one mole acid and one mole base. You know, you just remained at the border of the Russia. That's it. This is that's why you can't go to the U.S. In order to go to the U.S., you need show the extra requirements. Okay, you have to so increase the concentration of both acid and base, or you have to heat something, and then you can complete the reaction. Okay,
Okay.
does it make sense for you?
Yes.
And which problem couldn't you solve? Show me. Or if
Could
you
you show 52? The others are similar to this. The next ones. 52.
52. Okay, the 0.01 molarity sim the hydrolysis practically proceeds on the first step. So you know the first step, potassium sulfate react with the water, and it can forms this one. So is that clear?
Okay.
This is the first step. And your task is you have to calculate the pH. pH should be based on this one. And also and the constant, the hydrolysis constant, and the concentrate ionization degree. That's it. So imagine, so B mole forms, and salt 0.01 minus B forms, and the Kg equal to B squared divided by 0.01 minus B equal this. Just make the equation and solve that equation. After you found the B, you can find the pH, you can find the ionization degree, each of them. Now Kw.
How do I find ionization degree? You showed me how to find hydrolyzation degree.
Yeah, the ionization degree, you know, the ionization comes first before the hydrolysis. In the hydrolysis, the salts, the salts, the salt parts can participate in the ionic form. First, this salt should ionizate into ions, and then it can affect with water. Okay. In your case, the first step this is this one forms if 1 mole. Okay. Imagine in total you have 0.01 and let it be 0.005 molecules dissociated into ions like this, and formed 0.005 moles of these cations, and these cations can interact with water and forms this one. Is that clear? Ionization, it means whenever you found B, you can find the ionization degree. You just divide the B by 0.01. It's equal to hydrolysis degree. Is that clear?
The ionization degree will be what is this?
Which one? So this is the, pointer. I'm just pointing. 1 mole forms 1 mole, 0.1, 0.005 forms
The
0.
ionization degree will be 0.005.
No.
I mean,
I'm just
it's going
example.
to be equal to B.
No. 0.005 is not real. I'm just explaining.
No, like, yeah, for which one are you putting? For B?
Yes, you
An
have to
example of B?
yes, you have to find the B.
So 0.005 is an example of B.
Yes, it is an example of B, but it is not a real number for B.
Okay, I understood. Just an example. Okay.
So are you solving the problem?
Yeah.
So after you finish this problem, we came to the last type of the problem. Okay, can I explain you the problem number 57? You can solve these problems at home because you know the way of solving these problems
Okay.
because you're losing your time. So
Okay.
this is similar, and here we have new type of the problem. 57. If a sample of zinc is added to a solution of iron chloride, a gas can be observed. Explain the phenomenon, provide support for your reasoning by the proper chemical equations. So, did you get this problem? Your ideas? Why gas formation can be can be observed for this reaction?
Can you repeat your question?
Why can we see the gas formation for this reaction?
Do you mean liberation?
Yes, we're just adding the metal into the solution of salts. And why can we see the gas formation? Okay, this is a complex problem because two kind of reactions is occurring here. First of all, a solution of iron chloride. The solution of the iron chloride. So water. As you can see, the products acid and basic salt. This salt cannot react with zinc, but this acid, it is a super reactive with zinc. And let's see the reaction between the zinc and this acid. We need two more. Hydrogen. And then this hydrogen gas liberate from the solution. Did you get it? Because a solution of iron chloride includes acids. These acids can make the zinc form the hydrogen release of gas. This is the proper chemical equations. The hydrolysis of the iron chloride and the product of the acid, and the zinc can react with that acid, which is formed by the hydrolysis reaction, and then this gas forms. Is it
Okay.
clear?
Yes.
So can you just write down and then solve the 58, which is similar to our problem?
So I have to write this in words, right?
Yes, you have to write, you have to copy down the 56 problem, and then you have to solve the problem number 58.
This will take place because it will have two reactions.
So you have to explain me what kind of gas is liberating and why
No,
it's
I'm
liberating.
talking about 57.
Okay, and yes, it takes place exactly because in the
Could you
solution.
tell me the definition of 57?
So do you want to write down?
Yes.
Okay, the main reason why the release of gas can be observed is about the concentration of acid in the solution.
The main reason why the gas
Formation can be observed in the solution is the existence of hydrogen chloride acid.
okay.
This hydrogen chloride acid can react with zinc and one of the products of this reaction is hydrogen gas.
Okay.
It is also noticeable that the hydrogen chloride formed from the hydrolysis reaction. Formed from the hydrolysis reaction of iron chloride.
Okay.
So, is that clear? Can you solve the
Yes.
problem number 28?
Okay, I'm done.
Okay, you are in the right way. You showed me the gas formation exactly, and the products are correct. Okay,
It will take place because of hydrogen sulfate.
yes,
And that's formed from hydrolysis process with copper sulfate.
yes. Okay, good job. And let's concentrate on the next problems. And do the hydrolysis of aluminum acetate and aluminum chloride differ from each other? And substantiate your answer by the proper equations. Yes, of course. This one is neutral solution. This one is the acidic because acetate acid is weak, aluminum base is weak, aluminum base is weak, hydrogen chloride acid is strong. In that case, here the neutral, here the acidic. Just tell a few words, that's it.
What did you say? Aluminum acetate is neutral because
Because
is a
uh,
weak acid, a weak base, and is a weak acid. Okay.
two
Um,
parts of
okay,
the
okay, I understood.
salt is weak, and here one part of the salt is weak. Okay, and you may write the equations, but you can imagine them, yes, because you can write the formula of the aluminum acetate. By the way, can you write the formula of the aluminum acetate? Can you write?
Mm-hmm. Yes. There's something wrong. Is it going to be like this?
Yes, exactly. You're right. And you know how to hydrolyze this salt. Okay, and can you solve the problem number 62?
Two drops of aluminum chloride. Neutral, and the second one is acidic. I mean, the first one is acidic, which is with aluminum chloride, and the second one is neutral.
Yes, you're right. Because hydrogen chloride acid is weak electrolyte. That's why you can calculate in this way. And the next problem, which of the solutions reacts more acid? Okay. So here we have to concentrate on the valence of the metals. Here are the two valence. Here four valence. Oh, four valence. It means after the hydrolysis of the salts, we can take two types of the bases. Here, this base takes 2 moles of the hydrogen chloride in order to be neutralized completely. Plus water. But if this one 4, we need 4. That's why more acid relevance to this one.
Yeah, okay.
So others also be similar, and the table number only parents. Self-test the reversible hydrolysis of salts. You just and here are multiple choice questions um, in order to train your brain and check your knowledge. So the reversible hydrolysis of salts is always attended with the liberation of gases, occurrence of precipitate,
Is it C?
heat evolution. Let's say other answers. And the mass of is the transfer of electrons from one particle to others. Reversible reactions. It is It is electrolysis.
From right to left, left to right.
Yes, I know. So,
So diluting,
change
heating.
reaction of salt with water. Yes, exactly. Proceeds without the change of the oxidation states of atoms. This is also true, you know. Proceeds without a change of oxidation states of atoms. Yes,
Yes,
we can
yes.
see the oxidation number change. This is correct. But
C or E?
uh, C, it's incorrect. Heat evaluation. It is not relevant to our question. A heat evaluation, it is more about to changing the shift of the reaction. It is just kind of a requirement for shifting. It is not relevant. Now you have to find the correct definition of the reversible character of salts. So E1, it is a super character because we don't see the oxidation number change. And we can see also this one, D, is an exchange reaction, you know, the exchange reaction of a salt with water. You know, the definition of the hydrolysis. Hydrolysis, the answer is D. The answer is D.
D
Why?
or E?
It cannot be E. It is 80%. Why? Because we have neutralization reactions, which is not a which is not the hydrolysis reaction. Oh, so this is a neutralization reaction which occurs between acid and the base. Table salt plus water. The reactants is not reacting with the water, they are reacting with acid and base. You know, this is also process without a change of oxidation states of numbers. And here the supercharacter, it is an exchange reaction of a salt with water. Okay.
Okay.
If we say the reaction that proceeds without a change of oxidation states of atoms is the reversible hydrolysis of salts, we made mistake because there are some reactions that can occur without a change of oxidation steps that is not can be considered as a hydrolysis reaction. This is a neutralization reaction which can form without any change of oxidation number. And the D1, it is a definition. It can be definition because exchange means the shifting the direction of the reaction. As salt with water, the parts of the salts is are exchanging with a part of the water. It's correct because the water is the main reactant. So the answer is D. It cannot be E, it cannot be C, it can B, and also the A.
Okay.
If it is A, it is not a reversible, it is irreversible hydrolysis reaction because it is gas forming and the precipitates forming, which is not can be, which is not the irreversible character of the substances, because gas is going out of the solution, it's liberating, and precipitate, so it's also going out of the solution. So in that case, our answer is D. Is that clear? Do you understand?
Yes.
Okay, the all of the multiple choice questions is for you. Just solve them, and we will check.
What does the second question mean?
The salt hydrolyzes by cation. The weak point should be cation, because the hydrolysis can occur in terms of the weak point. In our case, the cation, the first question is sodium. Sodium is not weak; it's strong. And when it comes to the anion is an acid, it's weak. Uh, this salt hydrolyzes by anion, not the cation, because cation is weak, cation is strong. So 2 is correct, because zinc base is a weak electrolyte. Lithium barium. Only 2. Is that clear?
So acid should be strong.
Yes. Acid should be strong. Cation should be weak. In that case, the salt hydrolyzes by cation. And with that cation can form the non-electron.
Cation is an acid or in a base?
So cation is always the metals.
For hydrogen.
For hydrogen,
Cation is a plus, right?
cation, yes, it is a plus. Cation
Yeah, that's a.
can be met.
Isn't that for hydrogen?
It's also the hydrogen cations also. Yes.
So cation has to be strong.
No, anions is more strong because it grabs electrons. Cations lose their electrons, anions gain that electrons because they are strong. They are super electronegative.
Yeah, I remember.
That's why they are minus and the cations positive. So is that clear?
Yeah.
So this multiple choice questions are for you, and here the practical work. Here the laboratory experiments. You just have to read them and draw a conclusion. What happened and what kind of result did you get? This is just imagination. I know you don't have a laboratory in order to experiment this work. You just have to guess what may happen. Okay, just read them and you can draw a conclusion, and if necessary, write the equation of the process, ionization process, hydrolysis process. That's it. Okay, now
Okay.
you are free. I hope you can finish all of them. And then the next lesson we will continue our new topic, which is electrolysis.